So hello guys, welcome back to my YouTube channel. So today let's solve another LeetCode problem, which is 1466 point reorder routes to make all paths lead to the city zero. So we will solve this problem and it is a medium level. So let's try to understand and then we will write the code of it. Okay, and then let's start. So there are n cities numbered from 0 to n minus 1 and n minus 1 roads such that there is only one way to travel between two different cities. This network forms a tree. Last year, the Ministry of Transport decided to orient roads in one direction because they are too narrow. Roads are represented by connections where connections of I is equal to A of I, comma B of I. Represent a road from city A of I to city B of I. Okay, so rather than reading the description, I will directly tell you what is to be done exactly over here. Okay, so these all are the cities 0, 1, 3, 2, 4, 5. Okay, so these all are the cities, and this uh, these edges are the roads. Okay, from city 0 to city 1, people can travel from city 0 to city 1. So that's what this edge is representing. And for this, from city 0 to city 4, people from city 4 can travel to city 0. But our problem is we have to count is the people, the cities like 4 and 5. These all cities, people should be able to go to city 0. That's what we have to see. But over here, what we can see is as these are the edges are roads. So city 4 people can go to city 0, but city 0 people can't go to city 4. Okay, but what our problem is, all the cities people should be able to reach to the city 0. Okay, so city 4 people can go to city 0. So that is correct. That is a valid. And but city 5 people can't go to city 4, and city 4 then city 4 people can't go to city 0 because here the roads are for only this direction, which is away from city 0. So we have to not count this one because this city people can't go to 4 and then go to 0. So we will not count these edges or this road connections. Here these edges are called as connections. Okay. If you will see from 0 to 1, so city 0 people are able to go to city 1. Okay. From here, these city people can go to city 0. Okay. This city people can't go to city 0 as these edges are away from 0. Okay. It is going in opposite direction. So this city people can't go to city 0. The city 2 people can go to city 0. If uh, 2 to 3 they can pass, but from here to here they can't pass because the connections are opposite. So it can't be passed. But if this connection will be in the red direction, then the city 2, city 3, city 1 people can go to city 0. Okay. So wherever we can see the city 0 direction is going in the opposite direction, that all connections we have to count and that what we have to give an output. Okay. So how many are the connections which are away from, which is opposite of city 0? So 1, 2, 3. So output should be 3. Okay. So here everywhere there you have to do the same thing. In the example two also, what they have shown is wherever like from city zero, if the connections are coming inward, then we don't have to count that. But if the connections are outward, then we have to count. So these are outward, this is outward. So here two will be the outward. Okay. So that what is the problem saying us and how we can solve this. We can check if from here, if the person can go to this place, then we will give the count as one. Okay. And if this city people can go to this city, so we will increment the count as one. Okay. Initially the count will be zero, but by doing the depth first search, we will be checking if the connections are like inwards. So if the connections are outward, then we will increase the count by one. Over here, we can see it is inward. If it is towards the zero, so we will keep the count as zero. Okay. If the connections are towards zero, so one zero, we have to keep the count. And if it is inwards, then we have to keep the count as one. And later on, we have to just add all the count. So the count will become 1 plus 2 plus 3. So output will be 3. So by this way, we will do. Okay. I will explain you once again what I was trying to say. Okay. From 0, if the connection is going outwards, at that time we have to increase the count by 1. Same way from here. If the connections are going outwards, then we will increase the count by 1. If the connections are not outwards, inwards, then it will be 0. Wherever there is inward connection, 0 will be, we will initialize. We will keep the count as 0. We will increase the count by 0. And when the connections are outwards, we will increase the count by 1. And after that, what we have to do, we have to just count all the uh, outwards connection. So 1 plus 1 becomes 2, 2 plus 1 becomes 3. So by that way, we can get our desired output. Okay. So let's write down the code of it, and then I will explain you the code also. Let me erase this first. So what we can do over here is first solution will be there and define min reorder where there will be cell and will be there and connections. Okay. For this is a graph problem by the way. If you have not understood, we will solve this problem by graph. And for that, this is required default dig, and in round braces inside the default data structure will be list because here everywhere there is list, that is why. And we are using default link, so we have to uh, say that from collections we have to import default link. Okay, which is done. Then what we can do is this is the connection. So we will take 0 and 1, 0 as source and 1 as destination. Okay. So source comma destination connections. Zero is the source, one is the destination. Then what we can do is adjacent A, adjacent A, we have not kept as A, we have kept as source. Okay, source dot append, and in the list, what will be the destination, comma, one. Okay, from source to destination, if the connections are outwards, then we will keep the count as one or weight as one. Okay, for this tool, there will be destination. Here, opposite will be there. At the place of source, destination will come, and at the place of destination, source will come as RC, comma 0. And this is for outwards. Okay, like this. If the connection uh, means if the connection are inward, sorry, if the connection are inward, then it will be 0. So here I have kept that, and we have to traverse for each and every city and check, right? So we will use depth first search for that, and we will initialize city n is equal to 0. Okay, and count also is required, which will be the starting 0. Next, if n in okay, we have to initialize visit is equal to set. Okay, such that we are not counting the cities many times. We have to count the cities one time. So set it will not take a duplicate value. If 0, 1 will be there, only one. It's not if there are like many times it will not keep because it doesn't support duplicate value. That is a that is why we are using the set. Okay. If n in visit, if the city is there in the visit, then what we can do, we will return its count. Okay. Now we have to do for neighbors, weight adjacent, and if neighbor in visit, if the neighbor is in visit, then don't do anything, just check for the other neighbor. Okay, and count will become depth first search neighbor, count plus weight. Okay, and and lastly we have to return the count, and for this in reorder what we will do, we will return depth first search. I think the code is completed, and let's run and check if it is giving us correct answer. Return suppose bracket is not there. Sorry, silly mistake. And let's try to run it once again and see. Uh, it and is it we have to see that if that city is visited, then we have to add that such that we don't take that visit, we don't take that city once again. So this line is important. Now we running. Let's see if we are getting all the test cases running properly. Yeah, it is accepted all the cases, case to case three. Okay, so I will explain what I have did in this code. So first, we have to create an adjacency list, which will be a default div. Okay, and as we can see the connections 0, 1, 1, 3. Okay, so 0 I have to get source and 1 as a destination. If in the SRC 0 is there and 1 is getting, if the means if the connections are inwards, if the connections are inwards, for that we will keep the count as 0, okay, which is over here. And for this from destination to source, if the connections are inwards, then it will be 0, which is mentioned over here. And for the connections which are going outwards, we have kept this count as 1. Okay, count, or we can say the weight of these edges. And next, we have used the depth first search, search that would traverse. So first, we will initialize a variable called visit, which will be a set, and it will not allow duplicates. Okay, and in the depth first search, what we have initialized is n is equal to 0, is the city number, and count. What is the count? In the starting, it will be 0. And if we are checking if that city is in visit, if it is there, then we will return the count. If it is not there, okay, if it is there, we will return only the count of it, and we will add that visit. We will add that city in that visit. The visit will be given. And if it is not there, then it will come over here and for adjacent for adjacency list city. If neighbor is visit, neighbor, okay, so neighbor are like 1, 3, 4, 5, 6. Okay. If it is there in the visit, we will just skip that iteration, increase the count, and count will be the recursive call of depth first search where n will be our neighbor and count will be weight plus the count CNT. Okay. And after that, what we will do, we will return the count. And for this function, for this define in reorder, we will return the depth first search such that it can do for each and every cities, neighbors. And by that way, it will be doing and it will be giving us the desired output. Okay. Here 1 and 0, 1 and 0, why 1 and 0 are there? Because that if the connections are going outwards, then it will be 1, and if the connections are inward, here it will be 0. So here in the second one, it was inward, so it was 0. And for this, it was outward. That's why it is, I have written 1. Okay, so don't get confused over here why 1 and 0 is there. And this is the like a problem, and it is a graph problem. And if you are not able to understand, I will suggest you to first go and understand the graph data structure, graph how the graph problems are, and these are called edges. Okay, and there are this first understand the graph concept, and then you will be able to understand this. And what is the working of depth first search, breadth first search? That is important in order to understand this problem. So yeah, that's all for this video. And if you have liked the video, please like, share, and subscribe my channel. And I will meet you in the next video. Till then, bye bye. Take care.